It's easy to take laboratories for granted today. We picture gleaming benches, complex instruments, researchers in white coats.
Hmm.
But think about it for a second. The very idea of a dedicated scientific workspace, that was once as radical a shift as, say, the industrial factory.
It really was. And it's fascinating how scientific progress often comes from these unexpected parallels and just sheer dedicated effort.
So today we're taking a deep dive into the surprisingly recent origins of scientific labs, especially in psychology, which was just getting started.
And then we'll pivot a bit, looking at a really key moment in national science investment involving forestry research.
Right. And all our insights today, they're pulled straight from the journal Science, specifically the issue from June 1st, 1928.
Yep. We're looking at a piece by Harry-Ann Holmes from Oberlin College on early psychological laboratories.
And another by Irving M. Gray, which is actually a tribute to a man named William Barnum, kind of an unsung hero of scientific publishing.
And we'll also touch on the Sweeney-McNary bill, a pretty big piece of legislation from that same time, 1928.
So our mission is basically to unpack how scientific research got formalized, the bumps and breakthroughs along the way.
And how national priorities started shaping what science got done. It's kind of a shortcut for you to grasp a really foundational era.
Okay, so let's jump into that first big idea from Harry-Ann Holmes's article. These scientific labs weren't ancient history, they were surprisingly recent, and he links them to the Industrial Revolution.
Yeah, that parallel he draws is really illuminating. I mean, think about it. Before the Industrial Revolution, production was often decentralized.
Right, artisans working from home, maybe with an apprentice.
Exactly. More personal, maybe freer in some ways, but definitely less efficient for large-scale output.
And Holmes points out the Industrial Revolution itself kicking off with, machinery for coal and iron in England.
He even dates it back towards James Watt's steam engine. That's about 150 years before this 1928 article we're looking at.
So quite a stretch of history there.
Definitely. And the connection is, just like factories centralized making things and boosted output, sometimes massively.
Quadrupling it, the article says.
Right. The scientific laboratory did something similar for knowledge creation. It brought people together, standardized things.
Okay, makes sense.
But, and this is a key point Holmes makes, there was a drawback. Just like factory workers maybe lost some autonomy.
Scientists did too?
Kind of. He suggests scientists faced a loss of, let's say, personal freedom and initiative because of administrative controls, the demands of routine work in these new structured environments.
Huh. So efficiency versus creativity. Is that the tension?
That seems to be what he's implying. This drive for systematic, repeatable results might have, sometimes stifled the more freewheeling individual kind of exploration.
Interesting. So given that industrial parallel, where did these organized labs actually start? The source says Germany.
That's right. Germany, maybe 50 years or so after the Industrial Revolution really got going, following the Napoleonic Wars. The University of Berlin, founded back in 1810, kind of set a new standard for research universities.
Right.
But the very first chemistry lab, which is sort of the marker here, was opened in Gießen in 1824 by Justus von Liebig.
1824. And the article notes its 100th anniversary had just been celebrated in, 1925?
Yeah.
Just 3 years before this was written.
Exactly. It really anchors how recent this all is.
And then the idea spread from there.
Oh, yeah. Pretty quickly across Germany, Göttingen in 36, Marburg in 40, Leipzig in 43, England got its first in 1845.
And America.
Benjamin Silliman at Yale started the first American lab for teaching chemistry.
But were there precursors? I mean, labs didn't just appear out of nowhere, right?
Good question. The source does mention anatomy dissecting rooms going way back, maybe medieval Italy.
Okay.
And you had observatories, museums, botanical gardens too, so it was more of a gradual evolution, not like flipping a switch.
Right. Okay, so now psychology. This is where it gets really interesting. The first psychology lab was Wilhelm Wundt in Leipzig.
Yes, and Holmes, the author, gives the date as 1879. He actually mentions submitting an article to Wundt back in 1888.
Wow. And that lab's 50th anniversary was celebrated in 1926, just 2 years before this 1928 source. Psychology as a lab science is quite young then.
Very much so. Wundt's influence was just huge. His book, Grundzüge der physiologischen Psychology, came out in 1874.
The foundational text.
Pretty much. It really tried to establish psychology as an experimental science, moving beyond just philosophy.
And the source mentions this golden age in German universities around then. Yeah. People studying vision.
Exactly. Figures like Helmholtz and Fechner were already doing groundbreaking work on perception, building on folks like Kepler and Newton even. Wundt wasn't totally alone.
And his lab drew students from everywhere, right? Americans, Russians?
Absolutely. Which leads us straight to the American scene.
Okay.
The second psych lab in the world was started by G. Stanley Hall at Johns Hopkins. That was early 1883.
So just a few years after Wundt.
Very quick. And interestingly, Holmes, the author of our main source here, he founded the lab at the University of Pennsylvania in 1887. It opened with equipment in January 89.
And his lab focused on practical applications, like education, clinical work.
Yeah, moving beyond just basic sensation and perception into applied areas. It was quite forward-thinking.
And then things really took off in the U.S.
Oh, absolutely. You had James McCosh at Princeton, George Trumbull led, setting up a lab at Yale in 92, Joseph Jastrow at Wisconsin in 88.
William James's big book came out in 1890.
Right, The Principles of Psychology. And then by 92, Harvard and Cornell had major labs too, with figures like Münsterberg and Titchener. Psychology really took root in American universities very fast.
Amazing how quickly that happened.
Yeah.
Okay, let's shift gears slightly. There's another piece in this 1928 Science issue by Irving M. Gray. It's about someone named William Barnum.
Yeah, Barnum. He's presented as this really pivotal figure, but maybe one you haven't heard of. He was the editor at the Carnegie Institution of Washington from 1903.
And what made him special? The article calls him a practical man.
Well, Gray writes that Barnum had this incredible skill. He could take, say, a dense 50-page scientific paper and boil it down to just a few pages.
Without losing the essence.
Exactly. Helping the authors actually say what they meant, clearly and concisely. Apparently, the presidents of the institution really relied on him for that clarity.
His monument, the article says, was this library of over 500 volumes he edited on pretty much every scientific topic.
It really speaks to how vital that role of synthesis and clear communication is, doesn't it? Making knowledge actually usable.
Absolutely. Which connects back to your goal as a listener of getting information quickly without overload.
Right. Barnum's work highlights that generating knowledge is only half the battle, making it understandable, accessible. That's crucial, too. He was like an early information filter, pulling out the key stuff.
That's a great way to put it. Okay, one last piece from this June 1st, 1928 issue. It talks about a big national commitment to science, the McSweeney-McNary bill.
Yes, the Enlarged Program of Forest Research. This bill became law on May 22, 1928, just before the article came out.
And it was seen as a really big deal.
Huge. The Secretary of Agriculture at the time called it the most important piece of fundamental forestry legislation since an earlier act in 1924.
So it built on previous efforts.
It did, but it really ramped things up. It highlighted this understanding that research isn't just academic navel-gazing, it's the bedrock for practical development, in this case, managing forests effectively.
And it involves significant funding.
Oh, yeah. It laid out a 10-year plan, boosting federal funding for forest research from about $1 million a year up to a potential $3.5 million.
Wow, that's a major increase for the time.
A really substantial investment. And it covered everything: timber, forage, watersheds, fire prevention, insects, diseases. A comprehensive approach.
Involving multiple government bureaus, backed by public interest. It sounds like a real national consensus.
It really does. It set a powerful precedent for how the government could fund long-term, applied science for the public good. A systematic, sustained effort.
Okay, so we've covered a lot from just one issue of Science from 1928. What's the takeaway for you, our listener?
Well, we've seen how fields like psychology went from individual ideas to structured labs, kind of mirroring industrial changes, but with that tension around creativity.
And the importance of clear communication, thanks to people like William Barnum making complex science accessible.
Exactly. And finally, that McSweeney-McNary bill shows how big societal challenges like managing forests really need not just bright ideas, but sustained national collaborative effort and investment.
It's a great reminder that this whole infrastructure of knowledge labs, funding, communication, it's something that's constantly built and refined.
So maybe a final thought for you to consider as you look at today's huge challenges: climate change, public health, AI, you name it. How can these lessons from the past about setting up disciplines, funding big research, making knowledge clear, how can they help us now? What new kinds of labs or funding structures do we need today? And who are the modern William Barnums helping us make sense of it all?
Something definitely worth thinking about.